Okay, so I'm not live yet. Oh yes, I am. All right. So anyway, I've been updating my diagram schematic. So I just wanted to go over one or two little things, but I don't have the standard diodes in there anymore because I used some germaniums to rectify the signal that's on the input. Now the main issue at the moment is the coils I'm using are just single coils, but when the actual device is built, there'll be twin coils. So each coil here really represents two coils. So I won't need as much drive when I've got the main circuit built because and the coils need to be offset basically. So I'll probably have to put them in these empty vacant slots here and have the drive coil at the bottom down right down there, which you can't really see. So I'm going to put the drive coil right to the bottom, and I'm going to have the trigger coils basically on here, which is vacant, because my drag cancellation coils are actually at the bottom down here. So, and also I'll have to have trigger coils on the back as well, on the bottom as well. So, but yeah, but ideally I want to add an extension on so that I've got the drive section completely separate from the generator section. But yeah, I don't have to rush into that yet because I'm still doing some testing and things. But yeah, the coils need to be basically set offset from. Let me get my Let me get my piece of paper in a minute. I'll try and explain what. But so I've basically been looking at my side cross section view of my generator and the main generator section. And basically, the trigger coils need to be basically like this. That's trigger on and trigger off. So I've basically called it ton and toff. Right. So well, having the coils directly side by side is too close because, as you can see, the pole is directly overhead both coils. So when one coil is triggered, it almost immediately turns the other coil off again. So it doesn't work so well. So the coils need to be a little bit further apart, which is why I've kind of put them in a bit of a V shape at the moment. I've got an elastic band holding them out because my brackets at the bottom really aren't far enough apart really to hold the coils properly. So the coils ideally want to be horizontally at that angle instead of vertically at that angle, if you get what I mean. So anyway, the current consumption of the actual circuit, which will be on the circuit board, is less. It's going to be less than 20 milliamps actually. When it's stationary and it's not running, it consumes 20 milliamps, but when it's running, it uses 10 milliamps. So, so anyway, the coils basically need to be in such a way that as this rotor basically moves, it triggers a coil on over here about this point here. And at that moment, the coil that's in the middle, well, it's over here actually right now, but it would be down here. Well, it can be up there, it doesn't matter, because you see, these poles, these magnet poles here are the same, and these magnet poles are the same. So it doesn't matter if the coils are placed down here. It just means that it's going to go in the opposite direction. So anyway, so basically we trigger on. So the coil basically starts to push against this magnet, and its magnet's rotating clockwise, say for example, and it's pushing on there, and it's also attracting on this one here. So we've got push-pull happening at the same time. So the coil will basically push against that one as it's moving out of the way, and it will attract on this one, and as that one gets to top dead center, we want to turn the power off, because otherwise it will basically come to a complete stop, because we can't be pulling on this one anymore once we get to top dead center. So that's why this other coil down here will come into action and basically turn the power off again. So the cycle repeats itself as it's spinning. Now I've got the mosfet, the Chinese mosfet driver board down here, which is what's drawing power from this battery over here. The circuit over here, just to make sure I didn't get any interference or spurious noise, is getting power off this battery, which is what I was showing you, which is 20 milliamps. Now, I'm a little bit worried about starting this up while I'm actually holding this phone, because the thing flies. It really flies, and the motor, this magnet thing, it's not fixed. so it could fly off and roll across the room and smash into furniture. So you can see why I'm a little bit reluctant, but I am going to start it up. Now, I've got to hold it and stop it from spinning too fast because it really accelerates. It really moves. So I've basically got to hold it, and I'll probably have to stop it with my hand because once I get this going. So what I'm going to do is I have to put the phone down while I spin this because I can't just, I don't know, I'll try. But I'll try and spin it while holding the hand. But once it gets to a certain speed, there, it's starting to take off. Now watch this. Oh, it's not going fast enough. It's spin now. Look at that. It really accelerates. Now I'm holding it now to slow it down because it's going going really fast. So what I'm doing right now is I'm holding it, and as I'm holding it to slow it down, because it wants to go so frigging fast, you can see the current consumption has now gone down to 10 milliamps. Or when it gets faster, the current goes down even more. That's on the drive circuit. That's on the drive circuit, not the motor. The mosfet is using more power. The LEDs are lit pretty well. So I'm holding it to stop it from running away from me, because if I let go, it really takes off. Right, I'm going to stop it now, but I'm just going to stop it with my hand. Right, I had to stop it by friction because that thing really flies. Anyway, just a little update to show you what the situation is. It's once it gets to a certain speed, but it will start a lot easier when it's on the device, because the reason for that is that there's 2 coils triggering it. There's actually 2 coils for the trigger on and 2 coils for the trigger off, whereas in this situation I'm actually just using 1 coil for the trigger on and 1 coil for the trigger off. So there'll be more voltage and it'll start a lot easier when it's actually on my generator than it does on this jig, because this jig is just using a much smaller voltage. So I have to get this going faster to get started, whereas on here I could just give it a flick and it would be going straight away. So anyway, we get the idea, because basically it'll be push-pull, so there'll be it'll be working on 2 rotors. So instead of just 1 disc, 1 rotor, it will be basically one will be pushing and the other will be pulling, and then they'll alternate, so that when the one that was pushing before, this one will then pull and the other one will be push, so it will alternate. And because of that, we get much better torque as well, even more torque, and we should get less power consumption, because I'm going to be having the coils in series, not parallel. So we should get less power consumption and more torque, because this thing, I've only got 2S cells. That's 2S. So these are basically 7 volts. I'm only driving this thing at 7 volts and it really takes off. The current consumption, when I measured this earlier, was 350 milliamps. So it was, the MOSFET was actually drawing 350 milliamps when it's running this. It varies. If I move these coils, if I adjust the coils so the spacing slightly different, it can actually go up or go down. The coils need to be ideally placed to minimize the input current, but it's around 350 milliamps. It can go up to 400 milliamps or even half an amp if I get the coils further down. If I move the coils further down, it actually runs slower and it actually consumes more power. So yeah, just a little demo, and I managed to get going without actually knocking it off the table, which was something, because I tell you, trying to get this thing started, it doesn't actually take off until they get it up to a certain speed, because it doesn't generate enough juice to fire the LED. Let's just start it again. Right, I'm holding the phone, so it's just starting to fire there. There we go. I've got to slow it down because I'm afraid it's going to jump off the table. Ooh, it wants to really take off, that does. Right, I'll just stop it. Anyway, just an update on the situation, because I did a whole 2 hours or configuring this circuit, wiring it up and making tweaks and improvements to it. And most people don't have 2 hours to spend watching it, so I thought, well, I'll make a short update video just to show this thing works, and that's it for now. Thanks for watching. Where's the stop button gone?